I got a question from Brandon about how to find the min and max of certain trig functions, so let's look at this example. F of theta is sine theta minus root 3 cosine theta. To find the mins and maxes of this function, we first start by taking the derivative. The derivative of sine is, of course, cosine. Now, the derivative of cosine is negative sine, so that negative pops out, and you get root 3 sine theta. We care about the critical point, which is when the derivative is 0 or undefined. Well, notice here we're never going to have to worry about undefined because cosine and sine are defined everywhere. And since cosine is never 0 at the same time as sine, we can actually divide through by cosine, and we get 1 plus root 3 tangent theta is equal to 0. Solving this equation, we get tangent of theta is equal to negative 1 over root 3. In most cases, we wouldn't know what angle gives us tangent of theta equal to negative 1 over root 3, so we would then have to just use arctangent on the calculator and approximate it. But because this is actually a nice angle that gives us negative 1 over root 3, we know that theta is 5 pi over 6 or 11 pi over 6. These are our critical points, so we can make a number line for f prime, and we put 5 pi over 6 and 11 pi over 6 on the number line. And remember, the derivative is 0 at both of those places. And we know the derivative can only change sign at critical points. So we look at a theta value less than 5 pi over 6, like 0. F prime is clearly positive there because it's just 1 minus 0, which is 1. We do the same thing for a number in between 5 pi over 6 and 11 pi over 6, like pi. That time you get a negative. And then when you get bigger than 11 pi over 6, you get back to a positive number. Using our derivative, we can now talk about how our function is changing. So our function is increasing, then 0, then decreasing, then 0, then increasing again, which means 5 pi over 6 is going to give us a maximum, and 11 pi over 6 is equal to minimum. And that's how you can find the mins and maxes. Just note that sometimes we might actually need to say what the function's output of your mins and maxes, so you would need to plug in your 5 pi over 6, and you would get 2. If you were dealing with a closed interval, like from 0 to 2 pi, you'd also want to check your endpoints at 0 and 2 pi to make sure that you're not bigger than your local maximum or smaller than your local minimum. But in this case, you get negative root 3 for both of those. And of course, f of 11 pi over 6 is going to be your local minimum, which gives us negative 2. And now we see if we were doing the interval from 0 to 2 pi, you would have a global maximum at 2 and a global minimum at negative 2.